Welcome to this explainer of NSAuditor AI 0.36.0. Today, we're completely tossing out those standard, fluffy marketing feature lists. Instead, we're going to focus on something much more critical: zero fluff audit survival. If you are a compliance lead, a GRC professional, or, the CISO who actually has to put their name on the line and sign off on an evidence pack, well, this explainer is built specifically for you. So let's skip the noise and get straight to the evidence.
Okay, let's dive into this. Every single audit conversation you have will eventually run into the exact same hurdle. Look, the auditor is not going to ask, hey, what did you find? They fully expect findings. The real question, the one that literally decides how the rest of your assessment is going to go, is this: what did you leave out, and who said that was fine? Now you might be wondering, how do most teams handle this? Well, every compliance framework lets you accept a risk or mark a false positive. Because of that, literally every evidence pack has some kind of exception list. But here's the kicker. In most industry tooling, that exception is simply a name typed into a text file. And let's be totally honest here, a name in a text file is not cryptographic evidence of anything. Anyone with access can just jump in, add a name, tweak the rationale, maybe push out the expiration date, and nothing in the report can tell the difference. This, right here, is exactly where evidence packs die under scrutiny.
Think of an evidence pack as a formal argument, and a serious, seasoned assessor, they're going to attack that argument exactly where it's weakest. In practice, there are basically two weak joints that fail the most often. Joint number one: why is this specific vulnerability sitting at the very top of your remediation queue? And joint number two: who exactly approved that exception? These two vulnerabilities are essentially our roadmap for today. Everything we're about to cover addresses exactly how this new release fortifies these two specific joints.
Let's start with joint one, your vulnerability queue. Almost every queue you've ever worked is probably sorted by severity, right? Which usually relies on CVSS. But here's the problem. Severity is a counterfactual. It's asking how bad something would be if somebody actually exploited it. Picture a really busy Tuesday morning. You're staring down 40 criticals and you only have the engineering capacity to fix 6. A counterfactual is absolutely not the question you need answered. You need to know which of these is actually being exploited out in the wild right now. The solution here is Exploit First Triage, which brilliantly joins the CISA Known Exploited Vulnerabilities catalog and the first EPSS directly at scan time.
The consequence of applying this exploit intelligence is pretty stark, and honestly, it's a real game changer. It's summed up in one simple line: a KEV-listed medium outranks an unexploited critical. And notice the highly precise language we're using here. We specifically look at known exploited vulnerabilities. We never, ever use the phrase actively exploited because the data simply tells us that exploitation was observed at some point in time. In an audit, you absolutely must be factually precise. And this brilliantly illustrates exactly how that prioritization works in practice. The justification doesn't live in some separate dashboard. It rides right along with the finding. You get to see the KEV flag, the EPS score with its exact percentile, the CVE IDs that matched, and, crucially, the intelligence store's own as-of date. The catalog date and the exact specific reason for the priority travel with the finding itself. What that means for you is that your ranking is always something you can confidently date and defend when an assessor inevitably points to a row and asks, why is this on top? Which brings us to something absolutely crucial: a strict refusal to overclaim. Look closely at the specific band names used for triage. The names the developers outright rejected actually still sit in the source code right next to the ones they kept. They did not call the top band active, because CVSA entries are never removed. The catalog literally cannot support a present tense claim. They didn't call the middle band probable either, because an EPSS of 0.15 might be top decile, but mathematically that is nowhere near better than even odds.
Now consider the bottom band, baseline. We intentionally did not call it unlikely, and we definitely didn't call it safe. First's own guidance explicitly states that a low score is not evidence of safety. The governing rule here is that the bottom band must never encode a negative. It asserts nothing beyond not elevated. Similarly, when it comes to freshness, a stale, out-of-date catalog withdraws a negative rather than asserting one. It never falsely reports not exploited. It simply reports that it cannot say. Just let that strict honesty sink in for a moment. That's the credibility this entire tool rests on.
Let's transition over to the second weak joint: your exceptions. And here is the major 0.36.0 headline: every compliance report cryptographically verifies each suppression signature it renders for approvers whose registry entry carries key material. I am going to repeat that condition over and over because it is literally the difference between a true statement and a false one. Verification runs for approvers whose registry entry carries key material. This takes that whole trust me and totally approve this vibe and turns it into hard math that an auditor can actually check.
So it's absolutely vital that we drill down into this exact mandatory condition. The report verifies the suppression signature for approvers whose registry entry carries key material. You see, an approver's entry might carry their public key right beside its fingerprint. The fingerprint must equal the one computed from that key material. If they disagree, the registry is completely refused at load. This means a misdeclared member fails loudly, instantly, instead of just being silently trusted by the system.
Now, what's really interesting about this slide is how this verification process breaks down into two distinct axes for approvers whose registry entry carries key material. Axis 1 asks a process question. Should this suppression stand? Axis 2 asks a cryptographic question. Did these bytes actually come from the key they name? These two questions travel separately, and they only diverge on exactly one highly specific case, a key that was revoked after it signed the suppression approval. That divergence is huge. It turns signing after revocation from a mere paperwork observation into a concrete cryptographic finding. We also need to be crystal clear on the failure direction here. If an approver's entry only carries a fingerprint, well, there's no key material to check against, right? In that scenario, a missing verdict means not checked. It never, ever means failed. The report will simply read, signed, not checked by this report. Why? Because it absolutely must not falsely accuse your own hardworking team of forgery just because they haven't migrated to keys yet. However, if a record is actually tampered with, that renders signature failed verification immediately, no exceptions.
Moving beyond exceptions for a minute, let's look at the sheer scope of the evidence produced. Just one single, read-only, agentless scan maps out to 7 major compliance frameworks. That's a massive time saver. And notice the extreme specificity regarding GDPR Article 32. This covers the infrastructure substrate only. It's not some broad, sweeping GDPR compliance claim or a magical GDPR certificate, mostly because no such certificate actually exists under the regulation.
Let's move to and see how this builds directly on that concept of radical honesty in reporting we talked about earlier. As you'll see, every pack has a covered column and a partial column, but pay special attention to the third category, out of scope. That out of scope designation isn't a flaw, it's a core feature of this product.
As the premise goes, and it hits the nail right on the head, a scanner cannot produce board minutes, HR records, or a signed code of conduct. A tool that quietly just omits those non-technical controls is handing you an evidence pack with massive, silent holes in it. Instead, this tool lists every single out-of-scope control with a clear reason and a named operator side pairing. It tells the assessor exactly where the rest of your evidence is coming from. Let me tell you, that makes for a much shorter audit meeting.
Finally, we absolutely have to address data exfiltration, and we're doing it with strict specificity. All scan data stays safely inside your environment. No customer data is collected, transmitted, or stored, period. But instead of throwing around vague absolute statements like nothing leaves your network, which auditors hate, by the way, this outbound register enumerates exactly 17 paths. Each path has its trigger, its default state, and its off switch. If you toggle on offline mode, any configured egress paths are actively refused at startup. They are never just skipped quietly. This means true, verifiable air-gapped operation is a reality. To summarize our core differentiator today, practically every tool in this category will gladly tell you what it found. But an evidence pack that actively states what it did not check, a pack that clearly outlines which suppression signatures were cryptographically verified for approvers whose registry entry carries key material and which were only recorded, a pack that shows exactly which controls it cannot see and which catalog date your ranking rests on, that kind of honesty isn't just modesty. It is quite literally the only kind of pack that actually survives contact with an assessor.
So I want to leave you with this final, somewhat provocative thought to really challenge your own audit readiness today. When the assessor sits down in your very next meeting, looks across the table, and asks for your suppression list, what exactly are you going to hand them? A name casually typed into a text file or cryptographic proof? Take some time to really evaluate your own PECs. Thank you so much for joining me for this explainer.